In this lesson, we're going to get an introduction to the Mass Effects toolset inside of 3ds Max 2012. Okay, so to bring up our Mass Effects tools, let's go ahead and right-click right here in an empty space on our toolbar. And you'll see that we have our list. We have this Mass Effects toolbar. So go ahead and check that. And you'll see that my Mass Effects tools have docked themselves right here on the left side of my viewport. Now, they may have come up here to the top for you, and that's okay, or it might even shown up as a floating toolbar. So if you want to reposition this, you can just click and drag on the toolbox itself, and you can make it a floating toolbar. You can dock it up here, or right here on the left side. You'll see how it's given me a vertical box here. Okay, and that'll dock right there on the left. This is just easier for me to get to, so that's why I put it here. Okay, so let's go ahead and talk about the basics of rigid bodies in Mass Effects. Now, Mass Effects is different than Reactor. So if you're in a previous version of 3ds Max, you will not have the Mass Effects tools. Okay? Now, in previous versions, you'll be working with Reactor. In 2012, we have Mass Effects, and Mass Effects only has rigid body capabilities for now. Okay? So that's kind of why the Mass Effects toolbar is kind of small. We have our playback options, we have our rigid body types, constraint types, and then we have our Mass Effects tools dialog box. Okay. So with this lesson, what I want to do is just kind of give you an introduction to just rigid bodies and how they work in Mass Effects. Okay, so let's go ahead and select this rock here, and I'm actually going to go ahead and rename it. So let's just go ahead and call this boulder_01. And it's always a good idea to get in the habit of naming your objects as you create them, simply because in a dynamic scene we really need names. It's going to make it a lot easier to understand what all the different pieces are. Okay, so we have our boulder, and what I want to do is actually apply a dynamic rigid body type to it. And I can do this a couple of different ways. I can click right here on the Set Selected as Dynamic Rigid Body, or I could go to my modifier list and apply the Mass Effects Rigid Body modifier to it. Okay, and both are the same. So let's go ahead and click on the Mass Effects Dynamic Rigid Body. You'll see that that's applied itself as a modifier in the modifier stack. Okay. Now also in the Modify panel, you'll see that we have the rigid body properties. Okay, we have the rollout, and we can actually select which rigid body type it is from here as well. And we have our physical material, which is basically what material this object is made up of. So by default, everything is going to be set to none, but we can actually use a preset to set it to concrete, to steel, cardboard, limestone, rubber, or, well, steel. I already said that. And these are two that we're going to use in this project here, and these are basically the last used by Mass Effects in my specific version of 3ds Max. Okay. Now, let's go ahead and set this to concrete. Now, what this does as a preset is it goes ahead and changes all of these values, like our density, mass, static friction, dynamic friction, and bounciness, to basically imitate what concrete would be like. So its density is very high, so it's going to be a heavier object. You can see that the mass is very, very high here. We have 2 million some odd mass here. We have our static friction, dynamic friction, and its bounciness, which is very, very low. Now, if we set this to rubber, you can see that our density has changed, our mass has changed, and our bounciness has also changed. Okay. Now, you could also just go to none, and you can modify these values any way that you like. Okay. Now, in my case, I'm going to go ahead and just use concrete. Okay, because this is a boulder, so it's just going to be a rock, very large. We might take the density up a little bit higher if we wanted to, but I think concrete should be okay. Now, we've applied this dynamic rigid body type to this. And if we go ahead and hit play on our simulation, you'll see that it falls through our geometry. Now, if you've hit play on yours, that may not have happened. It may have gone ahead and stopped right about here on the ground plane. And let me show you why that may have happened. If you open up your MassFX tools, you'll see that in your world panel, you should have use ground plane checked by default. So let me go ahead and switch that back over to use ground plane. Let me close this. And let's reset our simulation. And basically what that's going to do is bring our object back to its starting point. Okay. Let's start our simulation again. You'll hit play. And you'll see that it stops. And it stops kind of on an invisible plane here. And let's go back to our MassFX tools. And using this ground plane, what that does is it creates an invisible plane along z level 0. Okay? And it will not allow anything to go into negative z. Okay? So let's go ahead and uncheck that, because I don't want that invisible ground plane there, because I've created a ground plane for this specific purpose. So let's close this. Let's reset our simulation. And in order to make this ground plane work that we've created, we need to convert this over to a static rigid body type. Okay? Now, the dynamic rigid body is going to work with the simulation. It's going to fall, it's going to roll and rotate as needed to conform to any other rigid body types in the scene. Okay? And it can affect other dynamic rigid body types. Now, the static rigid body is just going to stand still. It's not going to move. It's going to be something like your ground plane or a wall that you don't necessarily want to move, but it can affect dynamic rigid bodies. So in this case, we want our boulder to fall, hit the ground plane, and roll around among its contours. Okay? So let's go ahead and click and hold on our dynamic or our rigid body type, and let's hover over the set selected as static rigid body and release, and that will apply a MassFX rigid body modifier to our ground plane. And we can now use this as a ground plane instead of that level 0 ground plane. Now we could set this to a certain density and that sort of thing. We could go ahead and set this to concrete, but I'm going to go ahead and just keep it as none for right now. Now, one thing that you should notice on yours by default, it may have set everything to original, or it may have set itself to convex. Now, convex is the default mesh type, the physical mesh type. And this physical mesh is what is actually affecting the simulation. It's not the mesh that you've built out of polygons, it's the physical mesh. So as you can see here, we have this gray set of lines, and this is basically just a physical mesh that has been built around our actual mesh. Okay. Now if I hit play on this, you'll see that my boulder will fall, and then it kind of looks like it's hovering over the top of my ground plane, and that's because of the physical mesh affecting the simulation. Let's go ahead and stop that simulation and reset, and let's go ahead and set this ground plane to original. Okay. Let's hit start simulation, and we'll let this fall, and you'll see that it fell right through my ground plane, and it kind of bounced off, so it hit something. Okay. Now what's going on with this ground plane? Well, this is one of the rules or the violations that we have to simulations. If we go ahead and reset this, our ground plane is made up of a single plane, okay, that I've just created, and I've applied like a noise modifier to it and just shaped it to the shape that I need. But it's just a single plane, and that it doesn't have a thickness. So what I need to do is go ahead and go to my editable poly, and let's go ahead and add a modifier, and I'm going to add the shell modifier. Okay, I'm just going to give it some thickness. We can go back up to the MassFX rigid body, and now let's go ahead and start our simulation. And this boulder should hit our ground plane and then roll along it. Okay, so that's just one of those violations that you need to watch out for. Alright, so we've seen the static rigid body in effect, and we've also seen the dynamic rigid body in effect. Now let's go ahead and talk about the kinematic rigid body. So let's reset our animation, our simulation, and let's select this boulder out here. Let's go ahead and click and hold on our rigid body type and go to kinematic. Now, kinematic rigid body type allows us to apply traditional animation keyframes to this object, and it allows us to affect dynamic rigid bodies. So let's go to frame 10, turn on auto key, and I'm just going to pull this boulder out in the Y and up in the Z and turn off auto key, and you'll see that our boulder animates. Now what I want to do is go ahead and pull my dynamic rigid body type, and I'm just going to place it out in front of my kinematic boulder. And let's put them right over the top of one another. Okay. Now, if I go ahead and I hit play on this, my kinematic boulder will animate and affect my dynamic rigid body, but my kinematic boulder will not be affected by that. So let's go ahead and hit play. Or not play, I'm sorry, let's start simulation. There's two different plays here. We have play for our animation, and then we have play or start simulation. Okay, so let's start the simulation, and let's go ahead and actually, let's pull this down a little bit. There we go. Now let's go ahead and start our simulation, and you'll see that our kinematic rigid body has animated itself and affected our dynamic rigid body, which is still simulating. Okay, so you can see the difference between kinematic and dynamic. Now, one other really neat feature that kinematic rigid bodies have is that they can be animated until a certain frame. So in our case, we've animated this rigid body to go from point A to point B in 10 frames. Now I can actually tell it to become a dynamic rigid body at a certain frame, and that's what this until frame is. So let's check that, and let's set this to frame 5. So our object is going to go ahead and animate, and once it hits frame 5, it's going to stop animating and let dynamic rigid body simulations take over. Okay, so let's go ahead and start our simulation. And you'll see now it's a dynamic rigid body. And both of those objects have collided and are now simulating in real time. Okay, so let's go ahead and reset our simulation. And if we no longer want that, we can just uncheck that and start our simulation again. And you'll see that that object is now a kinematic rigid body. Okay. All right, so in this lesson we've taken a look at dynamic rigid bodies, static rigid bodies, and kinematic rigid bodies, and just looked at the basics of those three. And by now I'm sure you're getting all kinds of different ideas that you can do with your own projects, and what you could even do to this project, and just have all kinds of fun with this. I really enjoy dynamics. They're really fun to work with. And what we're going to do in our next lesson is go ahead and talk about planning our dynamic scene for what we need in our specific project.